Okay, now we are live. So are you ready for the material then?
Yes.
Think so.
Okay. Then we have part 2, the independent samples. It says one of the professors in the BYU Idaho Math Department collected data from BYU Idaho students to compare the mean wages of BYU Idaho male students to BYU Idaho female students. The students from his classes completed a survey which he then used to analyze if there is difference in these wages. And the first one is to design the study. So for the question, I just wrote down if there is any difference in the mean wages of male and female students.
Yep, that's just what I put.
Same here.
Stating the null and the alternative hypothesis, I have the null having mu1 equal to mu2, and the alternative mu1 not equal to mu2.
Right, that's what I got.
Me too.
Okay, so who wants to share number 4, collecting the data? Sorry.
So the data collection was once again right in the in the paragraph that he used a survey of the students that were in his classes.
That's true.
Yep.
And number 5 was, it says in a short paragraph, you submit a statistics to describe the data. After the paragraph, insert an appropriate and well-labeled graph to illustrate the data.
Now that one I just pretty much wrote, just what the mean one I had for the males was 11.935, the standard deviation 10.491, with
Yes.
the n equals 85.
Right.
And then the mean 2 was 9.759, standard deviation was 3.169, and the n is 91.
Yes. I did a histogram as well for each one of the data information we got. One for male and one for female.
Yeah.
What would I?
Okay. So then for number 6, it says make inferences. Letter A, what type of hypothesis test is appropriate? Which is written down the independent sample mean, since we have 2 different groups.
Right.
Correct.
Not being dependent on each other. And it says, are the requirements met for this test? Yes. Because it's normally distributed and it's a random sample.
Well, I put down that it was a population size was large enough so you can assume that it's normal, right? Because it is a large population in each one, but it wasn't necessarily truly a random sample because it was subject to only his students.
Right. Yeah, I was kind of wondering about that also.
And that's the only question that came up when I was going through it, because my first answer was yes, and then I got to thinking about it, and then whenever I went back and checked my answers, it said that it was not a random sample.
Yes, you have a groups of students, but it says that has students to compare the mean wages. The professors of the Idaho Math Department collected data from BYU Idaho students. Yes, we have the BYU Idaho students, but then it's not a specific one.
Yeah, it's only his classes. So, but I mean, that's part. I used that as part of my answer at the very end about what to do different.
Yes. Okay. So then it says letter C, compute the test statistics.
And so I got T with a value of 1.836.
Yes.
what I got. You could do plus or minus on that, right?
Yes.
It's plus or minus.
Correct.
0.836.
Yes.
Because that's ultimately it's your z-score is what the t-score is, and it's either going to be on both sides, correct?
True.
Now,
Yep.
greater than or less than, it would only be a plus or a minus, correct?
Yes.
Okay. All right. I just was having trouble understanding and remembering why it had to be plus or minus.
No worries. And yes, it's because we have both sides being shaded, both extremes, one positive and one negative. And then for degrees of freedom, I got 98.263.
Right. And did it ever show how they figure that? Because I just got it off the thing. I didn't know if there was a way to figure what that was.
Which one's that?
For the degrees of freedom.
No, I used the spreadsheet.
That's what I did. I don't think I kind of looked for it. I never saw anywhere where it said how to find that. I think it just said that we'd use the
right
spreadsheet for it.
The one being given, because right now it won't be a whole number as it was before.
Right.
That's what I read in that section.
Yeah. Okay. Well, yeah. I mean, from the spreadsheet, I got the 98.263.
Mm-hmm.
So,
Yes.
in the next question, as we move forward here, and looking for the p-value, how did you know what alpha to compare it to? Are you supposed to just assume that it's 95% whenever you start, or?
I think I just assumed because they said that was the most common.
Okay.
Correct.
So I just went with that. I didn't see anywhere where it said to, but
right.
So that's what I did.
Yes, it's not been specific,
At
but as well.
First I was calculating it at 99, and then I dropped it back down to 95, and it made a difference, but not that big of a difference.
Yeah.
Mm-hmm.
Okay.
Yes. Okay. So then the next one, as you said, it says to compute the p-value and compare it to the alpha level. So for p-value, I got 0.069.
Mm-hmm. Which is greater than the 0.05.
Totally right. So we failed to reject the null.
Right.
And that's meaning that we haven't sufficient evidence to show that there is a difference in between the female and male wages.
Correct.
Mm-hmm.
Then it says for letter H, rather than testing a hypothesis, now say you just wanted to estimate the difference between female and male wages of the 95% confidence level. Create a confidence interval to estimate the difference. I just went to the spreadsheet as well, and it came up with negative 0.176 through 4.529, and the other way around.
So
negative 4.
Why is it both ways? That help me understand that. I got the same numbers, but why do we have the opposite as well?
It's because we have a margin in between, having the margin of error. Remember, we need to add up and subtract on both sides for the negative and positive side.
Right.
And because, and this is just my own thinking, because we have two different groups and we have two different statistics. So there's, I'm thinking there are two different margins for female and for male. And we are taking just one t-score.
Right. I'm just trying to figure out why you have the lower bound at negative 0.176 in one, and then it flips over, and why you have the negative 4. I still don't quite understand that. I mean, that's where I'm struggling. I get it because it tells me that it's there, but I'll have to do a little more research.
I think, is it, well, with the t-score could be a plus or minus 1.836.
Right.
And so if it's plus 1.836, then, you know, that's in the middle of the negative 0.176 and 4.529.
Okay.
But if it was the negative 0.36, and it would be the opposite. It would be between a negative 4.529 and a positive 0.176.
All right, that makes more sense.
Mm-hmm. Okay.
All right.
Now then, for letter I, it says now interpret the confidence interval you built above.
So we're 95% confident that the true difference mean wages between men and women students at BYU Idaho is somewhere between either negative 0.18 and $4.53 or negative 4.53 and $0.18.
Yes.
And so when it asks for actions to be taken, this is where I put in that the action taken should depend upon what the question you're trying to solve truly is. If you're trying to prove that there's a difference, for better data, you would take a simple random sample of the entire student population.
Right.
Yes. That's true. Instead of having it very specific, switch it a little bit in between more students or different classes, not just one specific group.
Right.
Mm-hmm.
So that was my thoughts.
Okay. So then, would you like to move on to the quiz?
Sure.
Let me pull that one up.
All right.
The dentist and freshman here. We have to document dentist, office bills, and the freshman dinner.
I'm sorry, what's that?
That we will be using two different documents, the dentist, office bills, and the freshman dinner.
You broke up just a little bit, and I thought you were telling me you were getting ready to have dinner, and I'm like, well, I'm sorry, we're keeping you awake so long.
Okay. Do you have both documents open then?
I'm getting them.
Okay.
Yeah, mine's computer's going a little slow. It's coming
No
up now,
worries.
though.
It's funny when your children are upstairs singing their hearts out, thinking nobody can hear them.
But that's what they think.
Yeah. All right. All right. Both mine are open.
Okay.
I have the spreadsheets open that are needed. So. What? Gary, are you ready to go?
Not yet. I'm sorry. My computer's not loading those yet.
Okay.
Oh, there we go.
All right.
One of them came up. Okay, let's go ahead and we can get started, I think.
Okay. So then it says for question 3, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples? Mark all that apply. The first one, simple random sample was drawn from each population.
Yes.
We have both of them normally distributed.
Mm-hmm.
Yes.
And then the third one, the mu has to be More than 0 with this one, I'm not sure. The last one, of course, no. But
Yeah, so it's just the first two, right?
First two, yeah.
mhm.
Because you're testing to see if the mean is. Well, no, you're not testing to see. 0 doesn't relate in this one because they're related to each other. So all of your hypotheses depend on whether your mean from sample 1 is equal to, greater than, or less than sample 2.
That's true. So it doesn't really necessarily have to be with 0. Okay. Question 4. The test statistic for a hypothesis test comparing two means with independent sample is a t-score.
Or yeah.
As when it says two samples are independent, F. It tells you nothing about which. That's second option.
That is, yep, second option.
That tells you nothing about the second group. Okay, so who wants to read next one?
For the next 6 questions, use the data files from the dentist office bills. This data represents a simple random sample of dental bills at the dentist office in Idaho Falls and a dentist office in Rexburg. Let the mean of group 1 be the mean bill at the Idaho Falls office, and let group 2 be the mean bills at the Rexburg office. Okay, so perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill of the Rexburg office, which means we have the null hypothesis. Okay, so they've got that written incorrectly. The null hypothesis should be HO or H naught. Be U1 equals U2.
Correct.
So that's H null and H alternative being group 1 is less than group 2.
Correct.
Okay. Use the level of significance.
0.10.
Equal to 0.10. All right. 6.
First, it's asking for the degrees of freedom.
All right. Let me get this here.
Degrees of freedom, I got 37.996.
Let me just get that.
Just a second here. My keyboard's not up here.
Mean to 16.59. Division to 8.875.
This is group 1 is less than. So this is a less than test, is that correct?
At less than.
Right. The degrees of freedom I came up with 37.99.
Is that 37.996?
That's what I got.
That's what I got. Yep, 37.996.
And this is a 90% confidence interval because alpha is 0.1, correct?
Yes.
Correct.
Standard deviation for Rexburg, which would be group 2.
Mm-hmm.
206.
206.
Go ahead.
0.637. 206.637.
Yes.
That's what I got. Let me put that in. 206.637. Test statistic T-score. All right. Kevin, what'd you have for T-score?
That's what I'm calculating now. Just give me 1 second. Just entering the information. Okay, let me enter in here the mean. 60.059. This one, 208.5. Supplement for this one, and 1 second, guys. 5.7. 6.367. It's 0.90%. Plus 10. Plus 1 skip for me. 20 I'm getting negative 0.434.
That's what I got.
For the p-value, question 9, I got 0.333.
Just enter this into applet.
That's what I got as well, Kerry.
Let's turn to degrees of freedom. 1 second. I'm turning degrees of freedom now. 37.6. How much do you say are you getting? 667.
What was that?
For the p-value, entering the degrees of freedom 37.986 and a t-score of 0.434, I am getting 0.667.
Do you have it as less than?
Oh, yes, less than. Yes, I have both sides shaded. It's 0.333 is what you're getting?
Yes.
Yes, that's what I got.
Yes. 333. And this one is greater than 0.10. So we fail to reject the null hypothesis for number 10.
Right.
Then question 11 says, suppose instead that you had used the alternative hypotheses, sample mean 1 not equal to sample mean 2. What is the correct decision based on this evidence?
So that changes the p-value to the 0.667, which is also, it's still higher than the 0.1. So I believe we have insufficient evidence that the mean dentist bills between the two cities are the same. That's what I have.
That's the case. Okay.
All right. So it's still greater than, right, is what you said.
Correct.
Right.
Yeah.
Okay. So moving on to the next one, it says,
Hold on a second.
okay.
We have insufficient evidence that the mean dentist bills between the two cities are the same.
Right, the last option
Yes.
is what I put.
So if we reject the null, right?
Yes.
Is that correct? Then U1 is not equal to U2, so we have sufficient evidence that the mean dentist bills between the two cities are different.
Oh, are different.
Because the null would be that they are the same, and we just proved if our alternative was that group 1 was not equal to group 2, then that means that they're different, correct?
Yes. So we have
Sufficient evidence that the mean dentist bills between the two cities are different.
Well, did we? I don't. Is that? Do we have sufficient evidence? I don't know. I guess. I mean, because we have.
Yes,
Oh, maybe I'm thinking of this wrong. I think.
because it's asking if those are not equal, and of course that those are not equal.
Right. Right. Okay.
So then
You're right. Yeah. So,
If we reject the null, then we have to state the alternative hypothesis, correct?
right.
correct.
And so what the hypothesis U1 is not the same as U2, or U1 is different. So we have sufficient evidence that the mean dentist bills between the two cities are different.
Right. Yeah. I think. Yeah.
Yes, for question 11, yes.
Okay.
Okay. So we move on to the next part.
Okay.
Says for the next 6 questions, use the data file freshman dinner. This data represents the number of times freshman students from Utah and Colorado cook their own dinners in a month. Let mu1 represent the mean number of times a month that a student from Colorado cooks dinner. And let mu2 represent this mean for Utah students. Now you suspect that freshmen from Utah cook dinner for themselves a different number of times than freshmen from Colorado. Perform a hypothesis test to determine if your suspicion is correct. The null hypothesis is mu1 equals mu2. Use a level of significance of A equals 0.05. So what is the appropriate alternative hypothesis? So it's just does not equal, right?
Yes. Yeah, because it's Freshmen from Utah completed dinner for themselves a differing number of times than freshmen from Colorado, so it's not equal to.
So group 1 is Colorado, group 2 is Utah, correct?
Yes.
Yeah,
All
1 is Colorado, 2.
Okay, I've got them backwards and I need to change them. Give me just a second.
I did the same thing.
All right. Okay, I've got them. Confidence level on this one is 0.95, correct?
I'm sorry?
Confidence interval in this one here.
I'm just entering the information now.
Yeah, 0.95. Not equal to.
Not equal to. All right.
It's a group 5. 2 standard deviation. 8, 7, 7, 8.2. Are equal to.
What is the appropriate alternative hypothesis? So,
That the sample min 1 not equal to sample min 2.
correct. All right, 13. Test statistic.
Test statistic, I'm getting negative 0.845.
What I got.
Same here. Negative 0.845.
What is the p-value? I got 0.411.
Five, 6, 1. How much did you say, Kiro, you're getting for the p-value?
0.411.
So I'm getting 0.410. I don't know, it's making any difference. The applet. Entering negative 0.5. That's 0.411. Are you getting the same, Sean, for number 14?
0.411,
Mhm.
which is greater than 0.05.
So it failed to reject.
fail to reject.
Oh. So do we have to calculate this one up to get the margin of error?
So it's asking for the margin of error for the interval. It says determine 95% confidence interval for mu1 minus mu2 and estimate for the difference between mu1 and mu2 and put your answer below. Confidence interval.
All right. 4 squared 2 equals 3.420. All right. I have a calculation. I don't know if it's correct or not, but I have a calculation.
Okay, and what is the formula that you use? You use the one having the x bar minus sample mean divided by standard deviation divided by the square root of n?
I used the margin of error that was laid out in the lesson. T times the square root of S1 squared divided by N1 plus S2 squared divided by N2.
That was in this most recent lesson, you said?
Yeah. Did you guys find that one, or am I off on that?
No, I'm not finding that formula in here. And what specific section of the reading did you found that one?
It was in the lesson, it was in the videos, and it was in the reading. Where did I find that in the reading?
I'm not seeing it right off.
Let me do this. You guys see that at all?
Nonsense. Two multiply the square root of this one to the square and 1 plus this 2 to the square divided by 2. So it is 2 multiplied with the square root of s1 to the square divided by n1 plus s2 divided
S2 squared.
to the square divided by n2.
That's what it said. Let me see if I can find it again in.
I'm not seeing that anywhere.
Well, S1 equals the first sample standard deviation, and S2 equals the second standard deviation. N1 equals the first sample size, and N2 equals the second sample size.
So you're using the t, which is negative 0.845 multiplied by first one, which is 4.517 to the square divided by 10 plus 3.420 to the square divided by 12.
Where did I see that at? It must have just been in the, I thought I saw it in the reading as well, but it must have just been in the video.
In the video. Yes, I didn't check the tutorial for this lesson. So what you got, it's 3.968.
I ended up with negative 1.48279. which would be 1.483. Let me try it again here.
So I came up with negative 3.968. Let me do so again.
So when I take Okay, so when I walk through it, Kevin, and just see if it makes sense to you.
Mm-hmm.
So I put a t-value of negative 0.854, and then under the square root tail, I put the 4.517 squared divided by 10.
Correct.
Plus 3.420 squared divided by 12. So those numbers ended up being the 4.517 squared divided by 10 was 2.04. The 3.420 squared divided by 12 was 0.975.
Mm-hmm.
I added those two together and then
The square root of those.
took the square root of those and then multiplied that number by negative 0.854 to get an answer of negative 1.48279. Rounded up to negative 1.483.
As I did it again, maybe I'm missing some decimals. I came up with negative 1.467. Because the first time I just used the wrong standard deviation.
Okay.
Yes, I came up with negative 1.467. Let me give it one last try.
Carrie, are you able to calculate this as well? Did you see the formula that I had?
No, I never saw that.
Let me try holding it back up here and don't know if that. Can you read that at all?
Yeah, sorry, just one second. Let me just copy that down. Okay, I got that. Thank you.
Sean, just a question. Are you rounding at any point, any decimal point?
I may have. Let me go ahead and go back and just do it without doing any rounding. 4.517 squared divided by 10 equals 204.0403289 plus 0.9747.
So getting both of them added, I'm getting 3.0150289.
That's what I just got.
So
And if I
just
take-
get rid of that.
Mm-hmm. $1.736383857.
Mm-hmm. Yes. Yes, I'm getting a whole bunch of numbers.
And multiply that times
Negative 0.845.
854. Or did I write it down wrong? That's where the issue is I wrote it down wrong once again. I transpose numbers all the dang time. This is why I'm never not very good at math.
Just getting yesterday. I'm running as well. So then, did you get negative 1.467?
Yes.
Right. Is that what you got here as well?
Let's see. You got negative 1.467, right?
Yes.
Okay. That is what I got.
So it's asking us number 17 to input the lower bound.
All right, let's try it. I didn't enter that yet. Give me just a second. So, back to. Hello, buddy. What's up? You need to go ask your mama that question. You need to go ask your mama that question. Okay. I'm in class right now. You need to go ask your mom that question. Okay. Well, you'll have to wait then. All right. Sorry about that. Lower bound. Is that negative 5.147?
That's what I got.
Yes, that's the one been displaying here.
And the upper
2.214.
2.214, not 54.
Okay.
Okay. Go ahead and submit that.
All right, see what it says. $17 out of 19.
Are you good in math? Number 16, the one we just did for the interval.
Yeah, it says view the feedback here. See.
That's what I'm seeing. SPSS lower.
So where does it show your margin of error then in your Excel spreadsheet?
It's showing the standard error of the mean. This is 1.428.
So we missed question 11, the one that I talked us into.
But that's interesting. The idea is also hypothesis.
So did that feedback comment make any sense to either one of you?
Not me. I'm confused.
Because if it is telling us that it is less than what Excel says 1.428. So, and then the question, I'm sorry, the feedback says your result should be close to the answer shown. It says, so the answer given is the average between the two results.
So do you add the two together and divide them by 2? Is that what we do?
So then that's what I'm guessing. 1.467 plus the 1.428 divided by 2. 1.448.
$1.428 plus 0.987 equals, divide them by 2, 1.207 or 1.208.
So from where are you getting the, I got the 1.448, but then what you did to get the 1.208?
I took the standard error of the mean for both of them. The 1.428, added that to variable 2, 0.987, and then divided them by 2.
That gives you 1.2075.
Yeah. So another formula that I don't know if this is right or not. Margin of error is t times standard error of the mean. So now what happens if you take those two and then multiply those by negative 0.845? $1.021. Does that make sense to anybody else?
Where did you get that formula?
Well, that one I looked up, tried to figure out. I just Googled how to find the margin of error for an independent sample mean. And so it tells you that the standard error of the difference of the two means is given by the formula, which is that square root, which I showed you before. And then your margin of error ends up being your t value times your standard of error.
And you would just say the average of the two?
That's what like I said, Carrie, I'm honestly, I don't know. I'm just trying to use what I have.
Somewhere with a different formula. Let me if I can get what's
Can you hear the piano?
I can hear the piano, but that's okay. This may be one that we have to ask for help on.
Yeah.
So
no.
Okay. What's that?
No, that I tried to look up a formula.
Right.
I don't know. I'm baffled.
What's our degrees of freedom?
Like 16.562.
But it doesn't say anything about degrees of freedom in the formula.
Nope.
Let me try this again here. 4.517. $3.420 times 0.845. So using the same formula, but not writing anything out, I ended up with a different answer this time. So just using my calculator functions, using the same data input, I end up with a negative 2.54769, which would round up to negative. I just don't trust myself going outside of any formula other than what we were shown on in the lesson.
Yeah.
So here's my, do you have your calculator, Kevin and Carrie?
Yep.
So if I take 4.517 and I square that, divide that by 10, hit equals, and then I hit my, add that to, in parentheses, 3.420, square that, divide by 12, close parenthesis, equals 3.0150289. Then multiply that by the t-score of 0.845 plus minus equals negative 2547699.
Right.
That's the formula for margin of error in the book. I don't know what writing it down, where that messed us up.
It's because that's not even close to what we have in Excel.
What's that?
The margin that it's in the Excel spreadsheet.
Right.
It's not close to that one. Because the one given on the first test is 1.428. The standard error.
Okay. Well,
So
how do you guys want to proceed? I've got another class coming up here that I'm about 10 minutes late for. So should we just go back through it one more time?
As I think taking the feedback, we can go by what it says, make those add up, and having the average, which is 1.208.
Okay.
If we want, we can take that in.
That's fine.
That's just based on the feedback that was given.
Right.
Okay.
And then the other one we're missing is number 11.
Right. Which I don't get, because when we talked it through, to me it made perfect sense the way it was. So I'm going to go ahead and back out of here and start round 2 here.
Okay.
All right, so get this blown up again here. True save. True save. Set a random sample, and it's normally distributed. T-score. Two samples if you don't know what subject to. Degrees of freedom, 37.996. $206.637 for Rexburg. What's the test statistic? 0.34. What is your p-value? 0.333. Fail to reject. Save. 11. Suppose that you had used the alternative hypothesis. Okay. So if we had the alternative hypothesis and a p-value of 0.6, we still fail to reject, right?
Yes, because it's greater than 1.
Okay. So if we fail to reject, then that means we accept the null. How did I talk us out of this last time? I am sorry. If we accept the null, then we have insufficient evidence
that the midterm is between the two subjects. I'm going with option 4.
Option 4 is what I was thinking.
So if we fail to reject, it would mean that that group 1 is equal to group 2, correct?
Right, so would it actually be option 2?
Yes, that's what. Because our null is that group 1 is equal to group 2.
Mm-hmm.
Insufficient evidence.
Yes, I think option 2 sounds good.
Oh man, my brain is. That's what I agree, Carrie. I believe it's 2. I was on the right track. I was just the wrong. In my mind, when we discussed it, I thought we had rejected the null, and therefore we're stating that the alternate hypothesis was true.
Yeah.
How I got. All right. So 12. U1 is not equal to U2. Eight. 5. What is the p-value? 0.411. Save. Failed to reject the null again. Okay. So are you going to round those? Is that what your plan is?
I was just looking in the question and conversation.
Right.
There was a question about how to get a margin of error for the students asked.
Right.
And they said that the TA emailed her and told her to subtract the lower number from the upper number in the confidence interval and divide by 2. They said they tried that and it worked for them. I don't know if that.
So subtract.
That's just what it.
Confidence interval. So how in the world do you do that?
Subtract the lower number from the upper number.
So 2.214.
Yeah, so you take 2.214 and then subtract negative 5.147.
So minus 5.417 with a plus minus value equals 7.631.
And divide by 2.
3.8155.
I got 3.6805.
2.214 minus 5.
I mean, that's just what I had in the conversation part.
3.6805. 3.68.
Yeah, that's
all right. Let's try it. Yay. Negative 5 point.
That was it. The 3.681 is correct.
That's crazy. All right. My computer got really slow all of a sudden. I wonder if somebody got on my internet.
Oh no.
It's all right. As many kids as I got, that happens all the time. I don't know how I missed the test statistics. My fat fingers. Oh well. All right.
Okay.
Good enough. Good job, fellas. Way to go.
Okay, thank you, Karen, for the last one. I couldn't figure that one out.
Yeah, I wouldn't have known how to do that except for they asked that question earlier. So that worked out all right.
Yes. Okay, I think we'll lose Sean for the internet connection.
Yeah.
Okay. Well, we'll just
Okay, but when yes,
call
we
that
are all
good,
set then. So see you next
just plan
Tuesday
on
then.
Yep, next Tuesday. Sounds good.
Okay,
All right.
have a good night.
All right. Thanks, guys.
Goodbye.